Okay, good morning. Um, it's our last week of this class, okay, the 17th week. And we will go over some basic idea of language model this week. And of course, I will cover some real world experience of how to deal with malicious attack and malicious software, how to analyze them, okay, by using attack lifecycle. Okay, make sure you have scan the QR code. Okay, it's right here. Make sure you scan the QR code so the university knows you attend the class. Okay, and next week we don't have to. You don't have to go to class next week because that is our final exam, and due to the COVID-19, the final exam will be the same. The format will exactly the same as midterm. So I will give you a Colab file. Okay, so download it, store it in your Google Drive, and try to answer the questions. And maybe you have to write some code to analyze some data. Okay, so you have 1 week to finish it at home on your own. So you cannot discuss anything or show any code or document to your friend, to your classmate. You have to write it on your own. And I will announce the Colab file this afternoon. So you have a whole week to finish it. Okay, the due date and time is 9 a.m. next week, and July 24th. Okay, so make sure you send your final exam file, okay, to TA. Okay, and then we will try to grade your final exam and your final project within 1 week, so that you can get your final score, okay, within 1 week after the final exam. And that would be our class, okay, 18 weeks. So of course, due to the COVID-19, I believe the quality of the learning and teaching will be a little bit different from the face-to-face class. So we will try to be generous while grading your final exam and your final project. But you still have to give us still a nice quality of your exam and your final project. So I think that's the announcement. Okay, so let's go to our next two topics. Okay, the first one is I would like to review some attacks, malware behavior before we cover the attack lifecycle. Okay, so here is it. So in our previous slide, okay, T02, okay, our second slide, second Colab slide, which is right here. Okay, in that slide, okay, we cover some modern cyber attack, okay, including their taxonomy. They have different attack vector. Okay， 在中文里面 attack vector 你就把它当作是攻击手法吧，因为 vector 这个字蛮难翻译的哈。那英文就是 attack vector， 中文就是姑且翻译成攻击的手法。There are several different attack vectors. Okay, so I would like to review one of them so that we can understand what is attack vector. Okay, so we have discussed this example before. Okay, so basically let's do it again. Okay, it is a very old malicious software which is called Blaster. 中文叫做暴风蠕虫嘛。It is a worm, internet worm. Internet worm has several characteristics, which are right here: self-propagation and self-replication. That means this worm, okay, will initially execute it, okay, at right here. Will initially be executed, okay, at the attacker site, okay, and the attacker, which is also called infected host, okay, will execute such a malicious file. Of course, it is a PE file. It is a Windows PE file because it infects some vulnerability and exploit certain vulnerability in Windows system. Okay, and the attacker executed in the infected host. Okay, so what is self-propagation means? It means it will try to search among the internet. Okay, try to search if there is any victim, which is what we call target host. Okay, is there any victims that has such kind of vulnerability? Okay, this vulnerability lies in services, which is a default services in Windows XP, which is RPC, Remote Procedural Call. Okay, and this services works on TCP port 135. Okay, every Windows XP has such kind of services, and in a certain period of time, okay, this services has a vulnerability. Of course, Windows have patched this vulnerability. Okay, the blaster, okay, the attacker will try to search. Okay, so here we have. We'll try to create a first step. Okay, create a registry. Registry is a data. You can imagine that it is a database stored in the Windows system, and there are several settings. There are several values can be stored in the registry repository. Okay, so the blaster will try to create or check a very special value in that registry database to see if this infected host has been infected or not. Okay, so the very first time, of course, it is not infected, so we will try to create a value and store it in the registry database. Okay, and say, okay, that is the first time I infect this host. Okay, but after it infected the host, every other time when the blaster been executed, okay, it will check against it with the registry database and see, okay, there's a value which I stored before, so this host has been infected, so I don't have to infect it again. Okay, so that is a step number one. That is why it created a value, a registry in the registry database. Okay, and after that, okay, for the second step, okay, it is a probing, because the blaster worm would like to propagate itself to another victim with target host. So it has to send a lot of different props to the host in the internet, and the target is randomly chosen by the attacker. Okay, so we know IP address is it's a four numbers, right? Start from 0.0.0.0 to 255. Okay, 4 to 55. Okay, of course some of the address is not used. Okay, but however, we have a spectrum. Okay, it is the spectrum of IP address. So the MS Blast worm will try to randomly select I think about 20 IP address among the spectrum. Okay, so randomly select one and send some prop to the victim. Okay, suppose let's assume the right hand side is one of the target host selected by the attacker. Okay, so basically because it is TCP services, so you can send some initialization or we say establishment packet, okay, to try to know if such kind of service is indeed, okay, on the target host. Okay, so the step number 2, attackers send some props. Okay, try to connect to the RPC services. Okay, and that's step number 2. Okay, there are some other behaviors. Okay, step number 3, the blaster at the attacker site, it will try to check the date, and if the current date is matches to the matches a certain predefined date and time, it will try to attack the website, okay, which is windowsupdate.com. Okay, it tried to do some flooding. Okay, it's DDoS, deny of service, which means send a lot of packet, try to consume all of the resources on the windowsupdate.com. So the memory, the network bandwidth, the disk, the CPU resources will be consumed quickly. Okay, because all of the attackers around the world will send a large amount of packet, try to knock down the windowsupdate.com. Okay, but it only happens in a specific day and time. Okay, so it's step number 3. But however, we'll see this one. Okay, step number 4. Since the attacker tried to exploit, okay, the vulnerable services, so it has to, okay, send some specific, okay, very abnormal packet, okay, which contain the exploitation code right here. Okay, so step number 4, okay, send a very strange, very abnormal, it is an abnormal packet which contain a very specific byte. Okay, this byte will trigger the vulnerability in the RPC services. Okay, so after the RPC services receive such kind of abnormal packet, okay, so then 4.1, step 4.1, okay, the service handle such kind of request, and unfortunately it crashed, okay, due to some buffer overflow vulnerability, it crashes. So the RPC service now is dead. Okay, but before it dead, okay, the exploitation code will launch another process on the target host, okay, which is called a shellcode. Shellcode, basically it is a command line interface. You can execute some command in that process. Okay, so that is shellcode. Okay, after that, okay, 4.2, the step number 5, okay, since the RPC service is dead, okay, so the attacker will no longer communicate or send any messages, data between the attacker and the victim. So the left-hand side, okay, the blaster code, okay, then we'll try to communicate with the shell code, okay, because it is not it is still work, okay. So connect to the shell code and try to communicate with the shell code, try to exchange some data, some command line in that connection. Okay, step number 5. Step number 6 and number 7. Okay, at the left hand side, okay, because the blaster worm code will try to propagate the PE file, which is msblast.exe PE files, from the attacker to the victim. So it initiates a file server, okay, which is a TFTP file server. Okay, it works at UDP port 69. Okay, so at the right hand side, the shellcode would establish would execute a TFTP client, which is another program, and try to communicate with the TFTP server at the left hand side and try to download the msblast.exe, this PE file. This malicious file. So the file will be transferred, will be propagated from the left hand side to the right hand side. So the victim gets the PE file, which is this file. So it can execute the PE file. And now the victim becomes a new attacker. And this new attacker will try to, again, randomly select some IP address and try to attack next random victims. So so on and so forth, so on and so forth. So we call this self-propagation, self-replication. Okay. So that is the entire we say entire all the undergoing behaviors process, okay, made by the attacker and between the victims. Okay, so we can understand that an attack, a malware attack, will be very complex. There will be several different steps, or we say phases. Okay, I would like to say something more about the step number 2. Okay, so when the attacker try to find the next victim, and of course, which I say that it will randomly select about 20 IP address among the IP spectrum. Okay, so and send the prop to the victim, but it is not always the attacker can find a victim, because when you randomly select some victims, okay, maybe that IP address is not issued by some administration organization, so that is an unused IP address. Okay, maybe this target, this victim, maybe it is a PC, personal computer, and it is shut down right now, so it cannot receive any packet. Okay, maybe this victim is a server, so it is online, so you can connect, you can prop this online server. But however, maybe it is not a Windows server, it is a Linux server, so that TCP port 135 is not open to the public, so you cannot send a packet to these services. Okay, or even it is indeed a Windows server, and it is online and it has RPC services. However, sometimes maybe this Windows server have patched this vulnerability, so that of course you can send some malicious packet to the patched RPC service, but this patched RPC service will not respond, will not be attacked by this strange packet. So the figure which I draw here, it is successful attack, right? But sometimes, okay, in some steps, the attack step, the attack procedure might fail to, for example, fail to find the victim, fail to connect it to the RPC service, fail to send the exploitation code, fail to, there will be a lot of different reasons this attack might not success. Okay, so but however, if you at the very first beginning of the blaster attack, I think most of the PC is infected by this blaster. Okay, so there are several steps. Okay, so try to remember all those steps. Okay, I will go to the next slide. Okay, so basically, I'd like to show you something about attack lifecycle. So please Google attack lifecycle. Okay, let's take a look at my computer. Okay, so here is it. Okay, when you Google attack lifecycle, okay, remember to click the images right here. Okay, you can see that there will be a lot of different figures. they're talking about attack life cycle. Okay, let's take a look at a simple one. Okay, I think this one is good enough. Okay, there are several different researchers or companies. They try to define. Okay, they try to make a taxonomy or ontology 啊，中文叫做分类学，或者是那个 ontology 叫做ontology 没有一个很好的中文翻译哈。ontology 就是知识的分类、知识的组成、知识的建构。好，这是英文哈，中文没有一个很好的翻译。它的意思就是说，我们怎么样形塑一个攻击从头到尾，所以我们才叫攻击的生命周期，好吗 ？OK。There are different researchers or companies, cybersecurity companies. They are trying to define what is an attack life cycle. Okay, it should be divided into several steps, as what we see in blaster attack. Right, there are several steps. They are trying to make itself executed. Okay, they'll try to find the next attack victims. They'll try to invade the next victim, try to exploit certain vulnerability, try to execute some code, try to communicate with each other. Of course, okay. I believe there are more than maybe a million or different types, different attacks, different malwares in the past few decades. But there are some researchers that are trying to organize them, okay, into several different steps. Try to see if they can profile, okay, or they can organize those behaviors, okay, into a framework. So sometimes we call it attack life cycle frameworks. Of course, there are several different frameworks. We will talk about 2 of them today. Okay, so that is one of them. Okay, if you can see that there's 7 steps. Okay, like this. Okay, 7 phases, or I think this one. Okay, yeah, about 7 phases. That talk about all the same things. Okay, those attack life cycle are identified, okay, or defined by some researchers. Okay, so I think which one is okay. I think that this one is good enough. Okay, because it's okay. That is very nice. Okay, so I think there are several different steps, and there's several, for example, right here. Okay, there are several different there are several time period for the attacker to prepare such kind of attacks. Okay, so I think let's first take a traditional one. Okay, so I think that would be better to explain some other next framework. Okay, that is good enough. That is big and clear. Oh, so usually those researchers, the first step of they will organize the different step. Okay, the first step right here is called initial reconnaissance. Okay, I think that is good enough because there's some explanation right here. Okay, so if you can find this figure, okay, the first thing is exactly the same as blaster. Okay, at the first beginning, okay, the attacker would like try to find some victims on the internet. Okay, of course the strategy made by the blaster is not that good because it randomly selects some IPs among all the IP spectrum. Okay, but of course there are some smart strategy. For example, you may infect the PC or laptop under the same Wi-Fi, or in the same company, or in the campus. That is more efficient, so that you don't. There are several strategies helps you to find the next victims. Okay, but we will not discuss it too deep. Okay, so there are some ways for you. So you can send a probing packet from the left hand side to the right hand side, from the attacker to the victim. Try to specify, okay, this IP, this victim, is currently online and it runs the correct operating system, okay, and the services would like to attack is running, okay, something like that. So usually the first step is reconnaissance， 中文翻译成侦查哦 ，reconnaissance 就是侦查的意思。So they try to search and gather information from among they will try to search and try to gather the information of the victims. Okay, try to make sure, okay, this is the victim I'd like to attack. This it has a correct operating system. It has a correct services I would like to attack. It is something like that. Okay, you have to gather the information. So the first is always reconnaissance. Okay, the second is initial the compromise. Okay, so if we take a look at sorry here, if we take a look at the the blaster, okay, the step number 4, okay, it try to send a malicious packet, and the malicious packet carries certain exploitation code, which is some byte. Okay, this byte will trigger the vulnerability. Okay, so the second stage, the second phase is always usually called initial compromise or initial access. Okay, or initial access. They will try to, we use the word attack vector, 中文就是攻击的手法. Attack vector usually it is defined as what is the very first time you, which means attacker, can access the resources of the victim. And how do you do that? And usually in most of the malicious software, it sends a packet, and the packet carries some malicious code, and your services will be hacked, will crash after it receives the malicious code. So that's called initial compromise or initial access. Okay, right here. Okay, we have a initial access right here. Okay, of course there are various attack vectors can do such kind of things. For example, for worm attack, okay, because it the worm trying to attack remote services. So basically, the initial access, or what we call the attack vector, is to send packet, malicious packet. Okay, but the initial access could be some other things. For example, if you would like to attack a human being, you would like to do social attack. What will you do? Basically, you can send him or her an email, right? And this email has a malicious attachment. So the human beings, the victims receive such kind of attack. You will click the email and to try to execute the file you send to him or her, right? So this kind of things is exactly fit the definition of initial access or initial compromise. So basically, the attack lifecycle we talk about right here, it should cover all different kinds of attacks, not merely malware attack or cyber attack. It's try to give us a framework about what exactly an attack is, and it's including different types of target: human beings, network, computers, your laptop, your program. Any kind of attack should be covered under this attack lifecycle framework. Okay, so there are several different initial assets, or we call attack vector. We will show you a list of different techniques in different stages later. Okay, so that is the second part. Okay, the second, the third, establish full thought. That means, or we will use this word. Okay, execution and persistence. Execution means when the attacker compromise your victim, and of course the attacker has some bad intention, right? So it will try to execute something. So in our blaster example, it will try to execute a shell code. So the shell code can receive or send command between the attacker and the victim, and then it will try to execute TFTP client, which is a file transfer client, and try to receive files, and then execute the received file. Okay, so that is the what we call execution right here. There's always some bad things the attacker want to do to your system, to your computer, to your network. Okay, and the other execution for blaster is right here, is step number 3, right? On a specific date and time, okay, it will try to execute deny of service. Okay, so all the blasted victims around the world, they will try to send a large amount of packet at the same time, at the same date, to windowsupdate.com. So the windowsupdate.com will crash on that date, on that time. Okay, so that is what the blaster try to execute. So that is the execution. Okay, so that is exactly what the attacker want to do. So the other thing is persistent. Okay, so persistence right here is step number 1. Okay, step number 1. What this persistence means? It means okay, you can imagine that. Okay, we have a P file and it has been executed by the attacker, so it will become a process, okay, in your computer. So after you shut down your computer, this process will, okay, your computer is shut down, so there will be no any process will be executed, right? So after, when you reboot your computer, okay, most of the time, okay, your operating system boot up and some process, some program will be executed, but not this nsblast.exe, not this PE file. So sometimes, okay, those malicious file, they will try to, as I mentioned before, they will try to memorize if it has been executed on this host. Okay, and even more, they will try to modify a register. Okay, and this specific register is used to when you reboot your Windows computer, okay, there's always tons of default programs that will be executed, right? So the attacker will register itself in the Windows registry, so that after your computer has been rebooted, it will be automatically executed because of the it registers itself to be executed when your operating system rebooted. So that is called right here. That is called persistence. It's called persistence. So we will stay here even if you turn off your computer, even if you delete it, even if you no matter what, when you reboot your computer, it will spill it, the malicious software will still be executed and try to find the next victim. So that is step number 3. Okay, execution and persistence. Okay, step number 4, escalate privileges. Okay, so let's go back to here. Okay, I think that is right here, 4.1 and 4.2. Okay, when the attacker try to when the attacker try to execute the shell code, okay, you have to remember one thing, is that this RPC service, okay, is a system service. It is a default service of Windows XP. So theoretically, the privilege level of this RPC service should be administrator. OK， 中文的意思是说，像这样子 default 的 services RPC service 通常它的权限就是管理者权限了。如果以 Windows 来说，应该就是 administrator 那个权限了。所以是一个权限非常大的那个的背景服务啊，背景服务哈。So if the attacker try to exploit this high privilege services, okay, so after this services has been hacked, has been exploited by the strange packet, okay, the blaster will take over the privilege level that the RPC service is. So it is administration privilege. So the shell code right here, the TFTP client, this process right here, most of the time, okay, most of the attacker, they will be administrator privilege as well. So it can execute whatever shell he wants on the target host. So that's called Escalate privilege. Okay, but it really depends on what kind of services you have, what kind of vulnerability you have, because not always the attacker can gain the administrator privileges. Okay, that is not necessary to be this one. Okay, so step number 4, okay, credential access or privilege escalate. Okay, so again, as we mentioned before, after your attacker attack the victims, okay, so it will continue to do reconnaissance, try to attack the next victims. So number 5 is still the same as number 1. Okay, initial reconnaissance. But however, in here it says internal reconnaissance. That means that it really depends on different attack strategy. As I mentioned before, you can randomly select victims on the entire internet, or you can select some victims in your subnet. Select the victims under the same Wi-Fi signal, in the same campus, such as it. So it says internal reconnaissance, but basically the strategy, the technique is very similar. Okay. However, the difference between step number 1 and 5 is sometimes, okay, for example, if you are in a company which has a firewall, so that maybe the attack vector you use, okay, in step number 1, initial reconnaissance, okay, because the firewall is between you, which is the attacker, and the victims. So maybe you have to take some very general approach to do such kind of reconnaissance. But after you attack one of the victims in the campus, for example, or in the company behind the firewall, then maybe there's some other technique you can use, because between those PCs, for example, if you want to attack the other victims under the same Wi-Fi routers, same Wi-Fi signal, maybe you have some other techniques you can use, okay, because you which means attacker and the victims, which under the same Wi-Fi routers, they don't have a firewall between the attacker and the victim. So there are some other techniques you might use. So there's reconnaissance, and then you can move to let's move that laterally 就是中文翻译成横向的移动就是说你攻进去比如说一个 WiFi 下面的某个人之后，你就可以移动到另外一个人身上。可是移动的方式有很多种，因为我刚英文讲过了，就是说在第一步骤里面，你从外部攻击一个随机的一个 IP， 你中间可能有 firewall 啊，对不对？比如说你在公司里面中有 firewall， 所以你使用的策略跟方法，可能跟你第5步你已经攻进去之后，你在公司里面了，那你在公司里面你想要感染下一个 victim， 那可是你在公司里面是没有 firewall 嘛，对不对？所以你使用的技巧跟策略可能就不一样，所以你的第5步跟第6步可能就跟第1步跟第2步有一点点不太一样，对不对？因为你中间可能就没有隔了一个 firewall 了哈。不过这个都很看攻击者采用的策略哈，不一定永远是这个样子的。好 ，so after you can move laterally for example to infect another company's PC or services. Okay, so and then you still maintain the presence. Okay, it's still the same as step number 4. So maybe you have a step number 8, which is you have some other, for example, right here. After you attack a PC, okay, and as we mentioned before, you SQ the shellcode, you SQ TFP file client so you can receive file, you SQ the MS path. But this kind of execution that simply just help you to move from attacker to victim and try to attack the victim. But in what exactly you want to do is step number 3. You want to infect as many as victims as possible in a very short period of time and coordinate all those victims to send DDoS packet to windowsupdate.com at the same day, same time. Right? That is exactly what you want to do. So right here, so we have a collection or exfiltration. That means what exactly you want to do to complete this. Right here it says complete the mission, to complete the mission. So basically, I mean several different researchers, okay, they will try to organize, they will try to categorize those behaviors into different steps. Okay, so that is one of the attack life cycle. Okay, that's very famous. I believe most of the figure right here, they are just some very they are some just slightly different from what I explained. Okay, but basically they describe the same thing. Okay, so that is 7 stage of attack life cycle. However, there is another very famous attack life cycle which is used by most of the malware or cyber attack researchers, which is right here. Which I say, okay, MITRE attack, MITRE-ATTNCK. Okay, MITRE attack. So you can simply just Google MITRE attack and you will see the front page of this website. It is an organization, so it is not a company. There are some communities that are trying to organize all the things. Okay, and you can see that right here, attack metrics for enterprise. Okay, so you can see that there are 14 different stages. Okay, so it's right here at the top of this table. Okay, there are 14, but but it does not map to the 7 stages that which we explained before. It just simply says, okay, we have 14 tactics. Okay, remember this word, 14 tactics. Those tactics are used by different malwares, different hackers, different attackers. Okay, not necessarily all of 14 tactics will be used in one malware. Okay, let me choose to use. Okay, I will use 5 of tactics, try to exploit vulnerable service, something like that. Okay, not all 14 are used in one attack, but if you find an attack, you can always analyze this attack and try to fit the behaviors you observed, okay, the evidence you collect, to fit them into these 14 different tactics. And for each, okay, for example, the first tactic is reconnaissance, right? As we mentioned before, reconnaissance is most of things. It's most important things you have to do before you do the attack, because you have to find the next victims you have to exploit, right? So here we still have this important phase, but it is named static. So it has a number TA0043. Okay, tactic. Okay, maybe we can see that. Okay, so you can click the link. Okay, and it will describe, okay, what is exactly reconnaissance is. Okay, it has an ID. It created some date. Okay, let's modify something. Okay, so we describe, okay, what exactly reconnaissance is. It is, so I can maybe I can make it bigger. Okay, the adversary 就是攻击的人就是坏人is trying to gather information they can use to plan future operations. So basically, it is probing. Okay, it is to gather information. So it is exactly the same as Blaster. The first, I think this the second step, right? What kind of information Blaster would like to get at step number 2? The Blaster attack now want to know if the IP is valid, if the operating system is correct, if the services is open to the public, so it can further use step number 4 to exploit the vulnerability. So basically, reconnaissance, okay, we write it. Reconnaissance, okay, it contains several different technologies that involves adversaries' activities or passive gathering informations. Although Blaster, some malware Blaster, they actively send packet to the victim, trying to understand what kind of vulnerability it has, if it matches to my attack. But sometimes some attackers, they say nothing. They do not send any packet to the victims. For example, if you, as an attacker, and your victim are under same Wi-Fi routers, under same Wi-Fi signal, you don't have to send any packet to your victim. You can simply just turn on your network interface card and listen, because the packet sent by your victim is broadcasted to the entire Wi-Fi range. So if you just open your Wi-Fi card and listen the signal sent by your victims, maybe you can figure out what kind of operating system, what kind of services is that the victim has. So here we say sometimes you have to do it actively, which means you send packet, you send props to your victim, or sometimes you simply just listen, because some information will be leaked by the packet sent by the victims under the Wi-Fi signal. Okay, so you can use this information to gather information that can support targeting, which is your step number 2, number 3, 4, 5, so on and so forth. Okay, so what exactly we want to learn? Information may include the details of a victim's organization, infrastructures, staff personnel. So basically, again, I have to mention it again. This kind of attack framework, they are not necessary. The target is not necessary to be a services or a computer. It can be a person, a staff, an organization, a network. So different kind of attack are all included in this framework, attack lifecycle framework. Okay. Before we take a break, okay, let's take some example of what kind of techniques under reconnaissance. Okay, if you take a look at this matrix, okay, there are 10 different techniques under the reconnaissance. Okay, and you can see that there are numbers right here, so you can click this and it says, okay, under the active scanning technique, there are 2 sub-techniques. Okay, so you can see that the index of active scanning is T1595, and there are 2 sub-techniques. One is called scanning IP blocks. The other is called vulnerability scanning. Okay, the index is 001 and 002. So basically, you can still click this matrix. Okay, this is we're under reconnaissance page. Okay, you can see that there's several different index. Okay, called active scanning. That is exactly what Blaster did. Okay, they are trying to send different props. They are trying to know if you are online, and they do it actively. Okay, so 2 different sub techniques. Okay, and the Blaster used this one. It tried to scan certain IP, but of course, for the strategy that Blaster use, they randomly select the IP, so that they do not select an IP block. Okay, Blaster use random select IPs, but here's a sub technique is called scanning IP blocks, which means the adversary may scan some certain IP blocks. Okay, several consecutive IPs to gather the information, but apparently Blaster's strategy is a little bit different. And of course, you can scan some vulnerabilities. If you send for some vulnerability, okay, if you send a prop packet, for example, if you want to attack an web server, okay, so you can send some web page request to the vulnerable IP server, vulnerable web server. The server will reply, okay, hello, I'm server Apache, and my version is 2.2.2, for example, like something like that. When you try to access their services, there are always a server will try to reply what kind of version, this server used, but sometimes it is a very old version, so that you can simply just look up some vulnerability dictionary or something like database or like that, try to figure out, okay, version 2.2.2, it has a very serious vulnerability, so that you can further attack them. So there was tons of ways to figure out how to find a victim. So that is one of the way. Okay, so of course there are some other certain reconnaissance techniques, such as how do I get the victim host information. Okay, hardware wise, software wise, firmware wise, configuration wise. Okay, get the victim's identity, which means I know who used this computer. Okay, credential, email, and police names. Okay, so that's more likely to attack human beings. Okay, to gather network information, what is the domain, which is the web domain that they used, and is it has a domain server, and what is the topology of this network, what is the IP address in the campus, in the company, if there's any firewall or any intrusion detection systems in your campus or in your company. You can do such kind of a reconnaissance. Okay, so if I recommend you just take a look at this web page. Okay, reconnaissance. All the other things, all the other pages. I think reconnaissance is one of the most important techniques used by the attacker. So you know how to gather information by these different techniques. I recommend you to take a look at this page. Take a look at the reconnaissance page. Try to feel how your information has been gathered by different techniques by the attackers. Okay, and we'll talk about all the other techniques in next hour. Okay, so it is 10 after 8. Also, please come back at 20 after 10. Okay, we take a 10-minute break. Okay, thank you.